Yep, in the mic, yep.
Okay, then we'll move it. Okay, so just to begin, so if I could introduce myself, Christine Kilpatrick's my name. I'm the CEO of Melbourne Health, Royal Melbourne Hospital, and I'd just like to introduce two very important people. Firstly, Dr. Mike Catton, who is head of the Victorian Infectious Diseases Reference Laboratory, which we call VIDRL, and Mike is also the Deputy Director of the Doherty Institute, which is a partnership between the University of Melbourne and Royal Melbourne Hospital. And I also have beside me Julian Druce, who is the head of the Virus Identification Laboratory, and he's been intimately involved in this very important piece of work. So I'll hand over to Mike and Julian.
Thank you very much, Christine. So look, could I add my welcome to all of you today here to the Doherty Institute. I'd just like to start by saying how pleased we are to have been able to grow this virus in a very short space of time directly from a patient sample, and that's an art. And I guess Julian is the artist who you'll possibly hear about on the technical detail, but much more importantly that we've moved immediately to share this with our international colleagues to provide a toolkit that complements the modern molecular techniques that are so useful in diagnosis and development of vaccines and medicines. So there are some things that are just much easier to do when you have the virus in your hands, and there are expert laboratories internationally that haven't had access to the virus, and so this step makes it possible for a lot of things to move forward that have been delayed, and we're just delighted to have been able to fill that gap in the space between 2 a.m. Saturday morning when the first case was diagnosed in Australia and Monday when we believe we had the virus growing in culture. So Julian and I will be very happy to take questions from you on anything you'd like to know. Thanks a lot.
So what's been involved in growing a virus, and what is the process? If you can step us through that, please.
Yeah, so look, it's an old school technique. The current diagnostics are very rapid and fast using molecular methods, but the old school techniques you have or rely on cell lines or cell sheets that grow in a single layer of cells on a flask, and you inoculate or place some patient material onto those cells, and you hope that the virus in the sample gets into the cells and infects the cells, and then will produce a pattern in the cells that demonstrates that the cells are dying, and that's what we see, and I think the image of that's been put up on the web, and so you can see that the cells actually die in the progression of infection, and so that's how we know the virus is happening. And we've used the same test on that material that we use in patients to assess the level of virus so that we know that the burden of virus or the amount of virus present is going up, and so we can prove that the virus is growing.
Is it a difficult thing to do?
So look, some viruses are very fussy in terms of the cells that they require to gain entry into the cells, so all viruses need the appropriate receptor on the cells to gain entry. So it's a little bit like a lock and key. And the virus has the key and the cell has the lock, and if the right things are present, the virus can get inside.
We happened to be hearing that it happened very quickly. Were you surprised at the rapid rate that it did occur?
Look, yes and no. We've grown a number of these family of viruses in the past, and you've probably heard of SARS and MERS coronavirus, and they both grow relatively quickly in cell culture. So in some ways it didn't. But the international interest is obviously fascinating, and the fact that other people have not yet grown it. But there's only been limited spread outside of China at the moment, so not too many people have had that ability, and we're uniquely placed here that we've got both a diagnostic lab that's doing that work, plus these old traditional methods in the one laboratory that can bring those two together.
Can you run through for us the possibilities that this now creates? What's the next step?
So, yeah.
I'll take that one. So, in addition to the molecular techniques that might be used in the development of vaccines and medicines, the virus can be used in the assessment of the effectiveness of vaccines particularly, and of medicines. It also gives us the opportunity to create a first-generation antibody test. And that's important both in the clinical management of patients who may be late in the illness and past the point where they're shedding the virus that we detect with molecular techniques. And it's also really important for us to look at things like asymptomatic infection with the virus, that possibility, or or mild infection that hasn't come to the attention of health authorities, and those patients haven't been tested and identified as cases. So really an antibody test is the only way to answer some of those important epidemiological questions, which get you to questions of how many cases and how does the number of deaths relate to the number of cases that you're seeing on the ground. So a great many things are possible with the virus that complement and add to what you can do with the fast and powerful molecular techniques.
If we were to start with the antibody test then, which obviously precedes the vaccine. At the moment it's being said that you don't know you've got coronavirus until you're showing symptoms, so you're saying that the antibody test will be able to prove if you do or don't before you start showing symptoms.
I should clarify, those clinical diagnosis is done when you recognise that you have a patient and you really need a clinical illness to have that patient front medical care. What I was talking more about is what are called seroprevalence studies, where you look at a population and you look at the rate of antibody positivity in that population so that you can find out what the wider number of patients that are infected is. So I think the mainstay of clinical diagnostics and public health will remain the molecular techniques because they're so fast and they're so powerful. The antibody techniques are a complement and help us understand the epidemiology of the outbreak in that sense.
How much further along then does this take you towards getting a vaccine?
Well, that's really outside my direct area of expertise. I'm not someone that develops vaccines for a living. I'm a public health person that develops tests and is part of public health responses. But it's a key step in development of vaccines to assess vaccines. Animal models are very helpful. So there are colleagues that are working in Australia to develop models to test candidate vaccines on. Having the virus is a crucial step to allow them to proceed. They thought they were going to have to wait for some time to import the virus from somewhere else. Now we are in the process of getting the virus to them.
When you say them, are you referring to the WHO?
I'm referring to CSIROR. That's one of the groups. So that's also here in Victoria, and that's a very expert lab that have worked in the past on animal models.
There's also researchers and scientists in Queensland that are trying to work
Quite true, yeah.
vaccine. So are you working hand in glove with them, or is it perhaps just with them?
I've actually seen an email in my email box that I haven't had time to read this morning because we've been so hard pressed. I have no doubt that conversation is about to take place, but I can't say that it has yet.
And then with that process, would it be that you would hand them over what you have formed here today, or is it that you would just liaise with the results of what you found?
Oh no, the intent is to get the actual virus. Well, there are several parts. The very first thing we're doing, which we're doing today, is to get genetic material extracted from the virus in the hands of public health labs in the various state jurisdictions, so they've got a positive control for their laboratory tests, because the testing we've been doing so far has been limited by the absence of a virus or often even a synthetic positive control. So that's the very first thing, because that's directly about public health capacity in Australia. And then the next thing we do is to then ampule up, and this is Julian's territory more than mine, ampule up the virus itself for sharing with expert laboratories that are recommended to us by the World Health Organization as the first internationally with which the virus could be shared. So we'll work closely with WHO and take their advice on who should receive the virus first.
Has culturing this dish been able to tell you anything about the virus? Have you learned anything new?
I'll defer to Julian on whether he learnt anything new looking down the microscope, but no, I'll let you take the technical.
Not really. Other than it may generate a lot of media attention, but no, look, it hasn't. It's grown like other traditional coronaviruses in the past, and so in that capacity, nothing new. I've been in contact with a colleague in Germany, Christian Drosten, who is also very familiar with coronaviruses, and he pretty much discovered SARS. And he has given his advice on when to harvest the virus for onward shipment to important laboratories.
And something that's a bit of the fun part to maybe mention is obviously although the testing can be done in standard laboratories, you shouldn't culture exotic viruses like this outside secure high containment laboratories, and they're hard work to get in and out of. So we've had on the flask of the cell culture a video camera that has been linked up to, and Julian was able to share with me the link, so we're able to look from home at how the culture's going. So when I get up in the 3 a.m. in the morning for a glass of water, can log on and have a look at how the cells are going. So that was a bit of fun over the last few days. If you're into that sort of thing, and I guess perhaps we need to get out more, but we found that quite fun.
How satisfying was it when you realised you'd been successful?
When did we realise?
How satisfying?
It was pretty satisfying because look it all feeds into the global health response and for a public health initiative, and it's a really important component in that because no virus has appeared to come out of China yet, and it appears that other people have had difficulty growing.
Yeah. So look, we were very pleased, and you actually saw us live on camera with the final test in the footage. I haven't seen the media coverage so far, but we were actually on film looking at the nucleic acid test, really confirming finally that we had the cultures. So I don't know, it was a rare show of emotion from me anyway. So
Have you sequenced this virus yet?
that's with our colleagues at the Doherty Centre for Genomics. That's when this is over, we have a meeting to advance that immediately. So that's the very next thing that we want to do, is move from having the virus and sharing the virus to sequencing the Australian isolate.
And that's the full genome.
Yes, we've already got...
We have short sequences from the diagnostic test which generate products that can be sequenced, and that helped us verify and validate the performance of the test.
From the short sequences you have, does this look like an identical genome?
It's an exact match to the sequence from China.
Yeah.
So is that probably good news? Because
it actually validates or tells you that your test method is spot on and you are getting the virus and it's specific for that virus.
But in answer to your question, what's the virus doing? The segments are too short really to shed light on the properties of the virus. We really need the whole sequence to look at that. I'd be surprised if there are significant changes from the prototype virus that's on the web itself. If there are any small changes, it's probably just interest in tracking the strain, slight evolution rather than fundamental change in the properties of the virus. But that's speculation on my part. That's just what I expect.
We hear that the sample arrived here on the 24th. Where did it come from? Was it a patient in Australia or China, or how did it actually arrive at the institution?
I'll take that. Yeah, it was a patient in Australia.
Was it one in Victoria or New South Wales?
It was our first diagnosis. So there's a running joke in public health that if something challenging is going to happen, it'll be the Friday night before a long weekend, and this didn't disappoint. So we were actually sitting down, Julian and Catherine Bond, who's in the audience, and I, to plan staffing for the weekend and do a handover and what we were going to be doing, because I'd been in a teleconference all afternoon, and we'd sort of barely sat down, then scientists were hovering at the door with, we think we might have a provisional positive. So that too, that was a bit of a, well, exciting's probably the wrong word, but it did get our attention. So then things flowed through the evening and the night. One of our staff came in from annual leave who was particularly expert in the sequenced till 2 a.m. when we were confident enough to put out the results. He worked on till 4 a.m. on another sequence to be sure. So it was a long night.
I know you said you're not a vaccine expert, but the speed at which you were able to do this, which was a little over 48 hours, does that give any hope as to how quickly we may be able to develop the next step?
I guess when we provide the virus to others who will bring their expertise to it, that will mean that, if you like, the cycle time on what they can do will be short. If it was taking 3 or 4 weeks to grow, it would obviously take them a lot longer. So yes, in answer to your question, that is a good thing, I think. I think the general tone of discussion internationally about the virus up to now was that it was hard to grow and it was slow to grow when it grew. And in our hands, at least, Julian's hands, green thumbs, that wasn't true. It's been quite quick. So I think that's a positive thing.
Your research has, not just research, but what you've done in the lab has been described as a game changer. Do you see, I guess, the eventual containment of the coronavirus starting here?
I think that's probably overselling what we've contributed a little bit. This is this is a step, it's a piece of the puzzle that we've contributed. It's very useful to the global effort. I don't think really that the global eradication of this virus starts here. I think that would be overselling what we've done, which is a good thing, and we're really proud and happy about it, but it's only one small piece of the puzzle.
Julian, is there a reason, you mentioned that other labs have struggled to grow this, is there a reason why you were able to do this and they weren't?
It's like I said earlier, I think it's just the unique position that we still maintain the old traditional styles of culture, which are very limited in resources in most labs now. Most labs do not have that capacity. And to have a bank of cell lines accessible, now we only routinely have 2 cell lines that are being maintained at any one time, but we have many more in the freezer, and we've evaluated those cells in the past to SARS, and so we're well placed for that kind of approach. So it just means that we've got the 2 parts of that puzzle together in the one laboratory, which makes us uniquely placed for that ability. For the diagnostic component, to then use that same patient material in their virus isolation component.
But to amplify on what Julian said, our business is being ready for these sort of things. So the tools that Julian's lab has at their disposal, be it a broadly active coronavirus detection molecular test that he had that we knew would work, even in advance of the sequence being out internationally, because based off SARS and MERS, we predicted that there will be events like this and designed a test that would predict it. So that was one way in which we were ready. And a simple way in which we were ready is that there are a couple of flasks of fresh cells ready to go all the time. So you're not having to prepare anything. You can go straight from when you have a positive on the molecular test to, as Julian did, putting as much of the sample onto the fresh cells as you are able to do, even if it's at some ungodly hour of the day in a long weekend. And maybe it was that.
Is there any correlation between how difficult it is to reproduce the cell lines with how easily the virus transmits?
I wouldn't draw a straight line between those 2 things, no, because there are so many vagaries of how easily viruses grow in the lab in cell culture that are nothing to do with how they transmit between humans. So
this doesn't inform you more on the transmission?
No, I wouldn't say that.
Could you tell us a little bit about the biosecurity arrangements? I imagine you must have very tight security.
We do, but if I told you, I'd have to kill you. So all I'll summarise in saying it is there is as much physical and procedural and electronic security in this building as we could build. Okay.
Is it more than is usually here? Like, have you additionally locked down because of this virus?
Because of how high the security was anyway, no, we haven't escalated that.
Just a question to clarify. You mentioned before that the current tests are a bit limited and that this will allow you to make more tests. Can you explain a bit about the limitations of the current test?
Sure. I'm really, I guess the main thing to highlight there again is the antibody test, and that it's quite technically demanding to try and make a test to test for antibodies if you don't have the agent itself. It's certainly hard to validate it in the absence of clinical samples. So I'd highlight the antibody test there, but it does quality assure the molecular testing that you're doing, having access to the real virus as well. It's really powerful computing available to us these days. There is software, like when I was a lad, at the sort of dawn of the era of molecular diagnostics and virology, it was all done longhand. It was pretty slow. Nowadays, software will design for you a test, and you can be pretty sure out of the starting blocks that it'll work for you. So there's availability of a prototype test in silico, as we call it, in the computer that you can be pretty sure will work, but you never quite know until you've got the real clinical sample, until you've got the real virus. So an incremental improvement in the molecular testing is available with the virus, but it's mainly about the other tools, and notably an antibody test.
And just to highlight as well, having the virus also allows quality control globally to be kind of enhanced, and everyone's assay or test to be kind of have relativity to them. So we can assess what the performance basis of everyone's test is by having a proficiency panel or the same material sent to every lab in the world that does the testing to see their performance, and everyone then gets a feel for how their test actually performs, and we can from that select what is in fact the best or most sensitive test available.
So that's also something we do here. We run a measles antibody testing proficiency program for more than 200 World Health Organisation labs around the world out of this building. Julian's labs run in collaboration with the Australian College of Pathologists a proficiency program for detection of mosquito-borne viruses, again around the world, to expert laboratories, so, and as well as collaborating with them to quality control amongst the expert public health labs in Australia that are our colleagues in the other state jurisdictions. So in that often we have an agent that, because of the security around it, others can't, then we often are able to produce non-infectious material, derivatives from that can safely be manipulated in other laboratories, and use them to ensure the consistency and quality of testing around Australia, either for the public health labs, if it's a specialised agent, or more widely as required.
Any further questions? All right, we'll wrap it up there.
Okay, thanks
as
everyone.
I said, we will try to...